In this slide, we would be seeing concepts related to Keeling curve and global warming concepts, which include global warming potential and understand the global warming potential for different greenhouse gases. Now, coming to concept of Keeling curve, so it was named after Charles D. Keeling, who initiated the measurements in 1957 for greenhouse gases. And if you see this trend, so this is an upward trend, long-term upward trend, and this is related to global warming. This increase in carbon dioxide is mainly because of combustion of fossil fuels, and this is confirmed from multiple sources of data which we have seen in previous slides. So the concentration of carbon dioxide is increasing in our atmosphere, and this concentration, increasing concentration is correlated with the world economy, with the time period when the world economy started generating energy from fossil fuel combustion. And if we see the past 50 years trend, increase in carbon dioxide, so each year on an average about 44% of the carbon dioxide humans released into the atmosphere. This is as per a study by Global Carbon Project 2020. So the increase in carbon dioxide in atmosphere each year averages 44%. Now, of the 56% that is removed, about 56% that is removed, about half is absorbed into the ocean and lead to ocean acidification, and the other half is absorbed by the land biosphere uh, because of the activity by the plants. So that is known as photosynthesis. So a bit less than half of what humans emit stays in the atmosphere each year. So about 44% of what humans have released remains in the atmosphere, and 56% gets removed. Of that 56%, half gets absorbed into ocean and half gets removed by the land biosphere by plant activities like photosynthesis. Now, if we see the chemical composition of atmospheric carbon dioxide, then it can be proven that the increase is due to the fossil fuel combustion. So for that, isotopic analysis is carried out. Now, what are isotopes? So if you remember from your chemistry classes, then isotopes are variants of the same element, but in that number of neutrons changes. So carbon has got 6 protons and 6 neutrons in carbon 12, but there are other isotopes of carbon like carbon 13 or carbon 14 which has got 7 or 8 neutrons. So the potential sources of carbon dioxide are volcanoes, then fossil fuels, and these release different amounts of these various isotopes. And a chemical analysis was carried out of the content of carbon dioxide in the atmosphere, and it was compared with the carbon dioxide released from the combustion of fossil fuel, and it was found that the fossil fuel carbon dioxide released from fossil fuel is the same is of the same isotopic composition, which is showing increase in the atmosphere over past 50 years. We can also see the carbon dioxide, or we can analyze the carbon dioxide which is there in the atmosphere for a longer period of time by checking the air bubbles which are trapped in glacial ice, and we can compare the carbon dioxide over millions of years to the carbon dioxide which has started accumulating because of increase in fossil fuel. So, and if we compare the carbon dioxide from the beginning of industrial revolution, so at that time the atmospheric carbon dioxide was 280 parts per million, and there were other greenhouse gases like water vapor. There are other greenhouse gases like water vapor, carbon dioxide, and nitrous oxide, methane also. Now coming to other concept, which is known as GWP, that is global warming potential. So uh, in terms of presence, methane is only zero point 0.8 ppm. So if you remember from the previous slide, so at present carbon dioxide is about 400 something 400 plus ppm. However, methane is only zero point 0.8 ppm. Methane was only 0.8 ppm at the beginning of industrial revolution, and at present it is 1.9 ppm. So from 0.8 to 1.9, this is very small as compared to 130 ppm increase in carbon dioxide. But when you compare the global warming potential, so uh, it is 28 times uh, high as compared to carbon dioxide. So the heat trapping power related to carbon dioxide is known as global warming potential, and its value has got very important policy implications, because uh, if we are able to reduce 1 kg of methane uh, into atmosphere, so it will be equivalent to reducing 28 units of carbon dioxide into atmosphere. So it will be reducing the emission equivalent amount of emission by uh, 28 times of carbon dioxide. So this has got a lot of policy implications, and the industries which are sources of methane are targeted because of this higher global warming potential, GWP. So from this slide, there can be questions related to global warming potential, Keeling curve, uh, carbon dioxide isotopes, and how over a period of time carbon dioxide has increased from pre-industrial level of roughly about 280 ppm to 400 plus ppm, and methane which has increased from 0.8 ppm to 1.9 ppm, and what can be the policy responses to reduce, and what can be the relative policy responses when we have got different greenhouse gases. So instead of targeting or focusing only on carbon dioxide, if we focus on methane, so how beneficial it will be for